Today we're going to be taking lessons on Chapter 1, Lesson 3, which is multiplying and dividing monomials. First, we're going to define what a monomial is. So you should be checking your definition in your vocab organizer, as well as making sure you get down your examples for this. Your textbook defines monomial as a number, a variable, or a product of a number and variable So what does that look like? Using numbers, a monomial could be 2 to the 4th power. It could be a to the 2nd power. It could be 6x to the 3rd power. All considered monomials. So this would be the number, this would be a variable, and this would be the product of a number and a variable, all together in one. Those would all fall under what a monomial is. We are going to learn how to find the product of powers. And a product of powers is to multiply powers with the same bases you add the exponents. So remember, product is a multiplication problem. So we're going to be multiplying powers. Example 1 in your book is to find the product of 5 squared times 5. Well, remember, I can rewrite 5 squared as 5 times 5, and then this one comes down as also times 5. If I rewrite that or squish it back together and write it as a power, it's 5 to the 3rd power. Remember that this 5 up here, if I don't see the exponent, there's an invisible 1 there. So if I follow the product of powers rule, it's the same as doing 5 and then 2 plus 1, just adding their exponents, which equals 5 to the 3rd power. I get the same answer no matter which way I do it. Example 2. C to the 3rd times C to the 5th.
The B baseballs cancel.
So I could rewrite 3 C's here and 5 C's here and then recondense them. Or I can just rewrite this as an addition power of exponents. C to the 3rd plus the 5th is the same as C to the 8th. One more. Example 3. Negative 3x squared times 4x to the 5th. Now I'm going to break this one apart, and I'm going to use my commutative property to do so and my associative property, because I want to show you exactly how these come apart. I'm going to rewrite 3x as negative 3 times x squared times 4 times x to the 5th, because after all, this is all just multiplication problem. Then I'm going to use my commutative property to switch these two around. Now it's negative 3 times 4 times x squared times x to the 5th. Well, we know how to do negative 3 times 4. Remember your integer rules, opposite signs, it's going to stay negative. That's negative 12. And then here I can follow that rule. X and then 2 plus 5 is the same as x to the 7th power. I want you to do A, B, and C out of your textbook. On page 24, pause the video, and I will come back and give you the answers. A, 9 to the 3rd times 9 squared. You should have 9 to the 5th. B, a to the 3rd times a squared. You should have a to the 5th. And C, negative 2m times negative 8m to the 5th. Remember, you always want to add that little invisible 1 there, so you know that you need to add it. Your answer is positive 16m to the 6th power. Okay, guided practice problems on 26. You are going to do 1, 2, and that's it. You're going to snap a picture of those answers, and you're going to upload them as part of your remote learning assignment for today.